Good morning, guys. We'll look at a few more applications of simultaneous equations. And in this video, I'm going to do 3 problems for you, 3 examples. And for each example that I do, I want you to write it down in your books. But I also want you to create an example of your own, a question of your own that looks like this example. So what I'll want you to do is, change these values around, right? Create your own problem that looks like each of these examples and solve it as your homework or as your exercise. So I hope that makes sense. If you're confused on that, please text me or send me a comment, and then I'll explain better or further. So we have 1,000 tickets sold, and adult tickets cost 8.5, children's tickets cost 4.5. A total of $7,300 was collected, and they want us to figure out how many tickets of each kind were sold. So we can say here that let adult tickets be X, right? And let the children's tickets, if the adults tickets are X, the children's tickets, let's say they are Y, right? Now we know that a total of 1,000 tickets are sold, so that means that the sum of X and Y, X plus Y, is equal to 1,000, right? The other thing we know is adult tickets cost 8.5 and children's tickets cost 4.5. And when you add up all of the money from the adults and the children's tickets, if you add up all of that money, it was $7,300, right? 7,300. So my second equation will be 8.5 times the number of adult tickets that were sold plus 4.5 times the number of children tickets that were sold. If I add up that money together, right, I will get $7,300. So now I have a simultaneous equation that I can solve to find the solution. Now I want you to solve using elimination because I want you to get more practice on elimination. But eventually, when we have got more practice on each of the methods, you'll be allowed to use any method of your choice, or sometimes it will be specified. So here, if I want to use elimination, if I look at the first equation, remember, look at the coefficients of x. The coefficient of x is 1, but here the coefficient of x is 8.5. If I want to eliminate x, I need them to have the same coefficients. So in order for this first equation to have the same coefficient as the 8.5, I'm going to multiply the whole equation by 8.5. And just reminding you, coefficient is simply the number in front of a letter. So if I multiply the whole equation by 8.5, I get 8.5x plus 8.5y is equal to 8.5 times 1,000 is 8,500. I think. So yeah, 1, 2, 3. Yep. And the second equation stays the same. 8.5x plus 4.5y is equal to 7,300. So if I want to eliminate x, I am going to subtract, right? Sometimes you will be subtracting, sometimes you will be adding, but as long as you look at if they are the same value, then you can subtract. So I'm going to subtract to eliminate the x. 8.5x minus 8.5x is 0, or 0x. 8.5y minus 4.5y, I think, is 4y. And 8,500 minus 7,300 is calculator. 85 minus 73 is 1,200. So I have 4y is equal to 1,200. I can divide by 4, then I'll have y is equal to 300, right? So the cost of a child's ticket, right? The question asks us how many tickets of each kind were sold. Yeah, so 300 children's tickets were sold. If I want to know how many adult tickets were sold, I'm just going to go to the first equation. I'm going to use this first equation because it says x plus y is equal to 1,000, but I've found that y is 300, and so I have x plus 300 is equal to 1,000. Then I'll subtract 300 and subtract 300, so I'll end up seeing that x is equal to 700. So the adult tickets were 700 and the children's tickets were 300. So that's how you solve an equation like this. And like I said at the beginning, I want you to go to this same question, right? Change these numbers, put any number you want here, any number you want here, and there, and there, and then try to solve for those values. Obviously, if you put a number like 1 here, then and you leave this as 8 and 4.5, then you will have to deal with decimals. So pick numbers like that are bigger than this or that are multiples of this. Do whatever you want. I mean, pick numbers here and then use those numbers to solve this question, and then write your new question and its solution, take a picture of it, and then submit it. That's what I want you guys to do today. Let's look at another one. Alex has more money than Meg. If Alex gave Meg $20, they would have the same amount of money, right? While if Meg gave Alex $22, then Alex would have twice as much as Meg. How much does each one actually have? Let's see. If Alex has more money than Meg, and then Alex gives Meg $20, they would each have the same amount. Let's say let's call the money that Alex have, let's call it X. Let's call the money that Meg has, we call it Y, right? So it says Alex has more than Meg, right? And if Alex gives Meg 20, so if Alex loses $20, then they have the same amount. So if Alex loses $20, the money she has is equal to the money that Meg has, right? I hope you guys can see this clearly. If Alex gives Meg $20, that means Alex is losing $20. That means we are subtracting 20 from Alex's money. Then that money that she will have left will be equal to the money that Meg has, because they will have the same amount. So that already gives us our first equation. And then this says if Meg gives Alex $22, so now Meg is losing money. If Meg gives Alex $22, right, Meg is losing, so that's why I have Y minus 22. Then Alex would have twice as much as Meg, right? If Meg gives Alex $22, so Meg loses $22, Alex would have twice as much as Meg. So how much does Alex have? How much does Alex have? That would be X over 2. I know you guys are wondering, why is it X over 2, right? If it says twice as much as Meg. If it's twice as much as Meg, then Meg only has half as much as Alex has, right? I hope that makes sense. Or if I multiply by the 2 both sides, then you can see that Alex, which is X, will still have twice as much as what Meg has left, right? So another way I could have written this is by just saying that after Meg has given Alex $22, after she has lost $22, what she has, I need to multiply what she has by 2, which is what I'm doing here, to get what Alex has, right? So yeah, simultaneous equations can be fun. So this is what I have. I have these 2 equations. This is the first one, this is the second one. I'm going to first rearrange them, and then I'll try to solve them by elimination. So this first equation was x minus 20 is equal to y. If I want to have the x and y on both sides, I'm going to subtract y this side, subtract y, and then I'm going to subtract y this side. Then I'll add 20 and then add 20. So the equation will become x minus y is equal to 20. This second equation, it's initially or currently it is 2y minus 44 is equal to x, right? 2y minus 44 is equal to x. What I'm going to do is I will subtract x this side, and then I'll add 44. Add 44. So the equation will become 2y minus x is equal to 44. Again, I'm going to rearrange this because I want it to be aligned. I'm going to put the negative x first, plus 2y is equal to 44. So I have 2 equations. I have 2 equations, this equation and this equation, right? The first equation is x minus y is equal to 20. The second equation is negative x plus 2y is equal to 44. I want to solve for x and y. Now when you look at these two equations, the x's already have the same coefficients. The coefficients of x are already 1 in each of these situations. So if I want to eliminate the x, all I have to do is add these equations, because this is a positive x and this is a negative x, and when I add the two equations, the positive and negative will cancel out to give me 0. So I'll just say positive x plus negative x is 0. Negative y plus 2y is going to give me positive y, is equal to 20 plus 44 is giving me 64. So that means that y, which was Meg, has $64. Okay, so let's go to the first equation. X minus 1. I need to use the first equation to get how much money Alex has. Sorry guys that my work is all over the place, and I'm not setting a good example of organizing your work, but I hope that your work will be better organized than mine. I don't have a lot of space to work with, but you guys have all your books. So in this equation, I want to find x, right? I know my y is 64 is equal to 20. So all I have to do is add 64 both sides, add 64, and then x is equal to 20 plus 64 is 84. So those are my values of x and y. That's how much money Meg and Alex have. Yeah. So what I want you to do for this question, you can even change these names if you want. You can put your name and your best friend's name or whatever, and then change these amounts of money, right? Change these amounts of money and then solve that equation as well, because you've seen how I've approached it, and I hopefully you'll be able to do the same. Last one, David buys 10 apples and 6 bananas in a shop, right? 10 apples and 6 bananas. So let's say the apples are X, or let's even use the same letters. Apples are A, bananas are B. They cost $5 in total, right? In the same shop, Ellie buys 3 apples and 1 banana. She spends 1.3 in total. Find the cost of 1 apple and 1 banana. So this one is kind of straightforward, because you have 10 apples plus 6 bananas costing £5, not dollars. And then you have 3 apples. This is David's equation, and this is Ellie's equation. Then you have 3 apples and 1 banana costing okay, this looks funny, 6 bananas, 1 banana, 3 apples and 1 banana costing 1.3 pounds. So I have 2 equations that are simultaneous, and I'm going to solve them by elimination. So when you want to solve by elimination or even by substitution, look for the numbers that have small coefficients. So if I look at this number here, the 1 banana in Ellie's equation, it has a coefficient of 1. So I can easily multiply by whatever the coefficient is in the first equation, such that these become the same. I can multiply this equation by 6, and then I'll have 6 and 6, and I'll be able to easily eliminate x. So what I'm going to do is I'm going to multiply this second equation by 6. So the first equation stays the same, 10 apples plus 6 bananas is equal to 5. And the second equation now becomes 3 times 6, which is 18 apples plus 6 bananas is equal to 1.3 times 6 is 7.8, I believe. Yeah, 7.8. Now since I want to eliminate the bananas, I'll just subtract. 10 apples minus 18 apples, I get negative 8 apples. 6 bananas minus 6 bananas, I get 0 bananas, is equal to 5 minus 7.8 is negative 2.8. So I'll have negative 8a is equal to negative 2.8. Divide by negative 8, divide by negative 8. So 1 apple costs 2.8 divided by 8 is 0.35. 0.35 pounds. Wait, how do you write pounds? Pounds. Yeah, you get the point. Okay, so now I need to find the price of a banana. Since I have the price of an apple, I will substitute it in any one of these 2 equations, but I'm going to choose Ellie's equation because the banana is already 1 banana. So I'll say 3a plus 1 banana is equal to 1.3. 3 times a, I got a as 0.35 plus 1 banana equals 1.3. So 3 times 3.5, sorry, 3 times 0.35 is 1.05 plus a banana is equal to 1.3. Subtract 1.05, subtract 1.05. So the banana costs 0.25 pounds. So yeah, remember what you have to do is change these numbers, right? Change these numbers, rewrite your question in your book so I can see what numbers you chose, and then solve that problem, and then submit your pictures. All right, bye.